First, step 1. Step 1. In step 1, what it basically does is it takes one element, then compares it with the next element, and if the next element is smaller, then it swaps the elements. That is 23 will be swapped with 1, and it continues till the last element, so that the largest element can be stored at the last. So in the first step, 23, 1, 10, 6, 9 and 15. So it will compare 23 and 1. Since 1 is smaller, so 23 will take the place of 1, and it will become 1, 23, 10, 6, 9, 15. It will be continued n times. N is the size of the array. One time, second time, it will compare swapped with 10, 1, 10, 23, 6, 9, 15. Now these two are done. 23 is here. We'll compare 23 with 6. Since 6 is smaller, so it should be placed before 23. 1, 10, 6. Here do not get confused with 6 is smaller than 10, so it should come before. As we'll proceed further, it will be sorted, but this time our focus is only to send the largest element at the last. So 23 will be placed here, 9, then 15. In next iteration, 1, 10, 6, 23 will go will be swapped with 9, 9, 23, then 15, and then further 1, 10, 6, 9, 23 is greater than 15, so it will be swapped, and 23 is now at last. Now this 23 is sorted. It is on its correct place. Now check the algorithm, the number of times we have iterated to send it at last. 1, 2, 3, 4, 5. 5 times. 1, 2, 3, 4, 5, 6. So first time we have done this also. So 1, 2, 3, 4, 5, 6. There were 6 elements, and we have performed 6 iterations to send it at last. Now step 2. Step 2. Here we have 1, 10, 6, 9, 15 and 23. I have written just what we had got in last step and in the last iteration. Sorry. Now you can see the array elements. Okay, 23 is sorted. So we have placed a bar mark over here, and now we'll iterate this through this part only. Here let us compare 1 with 10. 10 is greater element, so it will be where it is now. It will not be swapped, as 1 is smaller, 1 is before 10 and 10 is after 1. It will not be swapped. For let's say if I was iterating using I will be switched from 1 to 10. In the second step, 1, 10, 6, 9, 15. Now we're not talking about 23 as it has already been sorted. So since 10 is smaller than 6, 10 is greater than 6, so it should be placed after 6. So here we will do the swapping. 1, 6, 10, 9, 15. Now here 10 is greater than 9, again we'll swap 1, 6, 9, 10, 15. Now here 10 is smaller than 15, so 15 is the largest element. As we were taking the largest element to the last, here till this part we have got the largest element, that is 10. So we can see easily 1, 6, 9 and 10. 10 is the largest, and it will be compared with the last element 15, and 15 is larger than 10, so it will not be swapped, and 15 will also be sorted. So here the sorted part is this. There was 23. Now we'll take 1 2 3 4 iteration. 1 2 3 4 5. We have taken one more iteration to just list it down, as we have not swapped here. So the last part 1 9 10 15 23. So here it will perform from till the number of times the elements are left in the array, that is unsorted. So in step 3 we'll proceed like this: 9 10 15 23. We'll compare this with this, and we'll continue the algorithm as we were doing in step 1 and 2, since the array is already sorted. So we'll get, after all iterations, after further 3 more iterations, we'll get this array only, and it will be the sorted array. So final sorted array will be it will be 1 6 9 10 15 and 23. Now the time complexity will be big O n square, as we are doing this for n steps, and in each step we are iterating for n times. That is changing, but we are going for n times as the unsorted part of the array. So the complexity will be big O of n square. Now we will see the code part. This time we are doing this in Python only. So we will start with for I in range. We'll set a range, and it will start from